Welcome back. So we have seen the results of ARIMA model. Now we come towards the end where we are proposing a ARIMA model 011 and we want to check and be sure about whether this model is fit or not. Okay, so please understand, whenever we are talking about the fitness of a model, we do it on the residuals. Okay, and residuals can also be said to be errors, and we can be sure about the model we are proposing when the residuals are white noise. If there is a signal still remaining in the residuals, that means we have not proposed the right kind of a model. Okay, so how do you do it? There are several things that guide our thinking with residual diagnostics. So we'll begin with ACF plotting. Look at the this command in row number 31, ACF. I want to plot the ACF of the residuals. If you remember, I had plotted ACF in the beginning, pre-model building. ACF also comes handy as a visualization tool at the post-model diagnostics. Okay, so in ACF, I'm writing model. From model, take out the residuals and take out main correlogram. And when I do it, I run this script. I run this script and see how it looks like. This is the way your ACF plot looks like. Okay, and keep it hold on for a second. Let's plot the other residuals of the model and just run it. And let's see how it looks like. The residuals still have some kind of information, it seems, right? So not everything has been captured in my ARIMA model. There is still some signal as to there might be a presence of some information in the residuals, which is not a good sign for a model to be fit. Now let's talk about the normality here. I make QQ normal distribution of the residuals and I run the script, and when I see it, this is how it looks like. It may give us an indication that there is a normal distribution, but if I plot a line over it, I'll be more sure about what I'm trying to say here. So QQ line over the model of the residuals, and if I run it and then I see it here, I have this understanding looking at this that there is some issue with respect to the normality assumptions of the residual as well. So whatever tests we have done so far are giving a clue as to the presence of some signal left over in our residuals. That's not a good sign. Then let's check with some Shapiro-Wills test, which is a hypothesis test here. So I write Shapiro.test. On which I'm testing it on model, I am testing on residuals. So I run it, and this is how I get a Shapiro-Wills normality test on the residuals. The p-value is less, which rejects the null of normality. Support of this on Shapiro test, we can have another test to be more sure of the residual diagnostics. So I can put on box text, this is called as lung box text. Okay, so I do it at lag 20, because you can take a lag of 15, 36 or whatever you want, but 20 is good enough. So this lag selection, you can keep at least 15 minimum to start with. 15 on these 20 lags, I'm running a test that is lung box text, and I run it again, and it says again the p-value comes out to be less than 0.05. So in all of these tests, the assumption of normality is also not met for the residuals. Okay, let me see if I can make some other test which can help me comment on. So at this stage I am quite clear as to that I'm not expecting a great model, right? I would expect a great model with the minimum signal left over in the residuals, which is not the case in all the tests that I have run, is also the ACF and the normality plot that I have seen. Can I just see it through a histogram as well, which is considered as a very contemporary way of seeing the normality? And if I look at it, again, it doesn't give me a signal that the residuals are normal. Over this histogram, if I plot the lines also, okay, let me try to plot lines over this histogram and just see, does that help us? No, it doesn't help us. So in this, all these analyses are giving us some kind of a multiple signals as to the weakness of the model. But nonetheless, the last process, all you can do at this stage is you can make a forecast. Okay, so you are forecasting for 48 values. How do you go about it? So you create a new object and place it in F, and the moment you do it, you will find its presence coming in this environment. So you forecast and you run it, right? You run it, and then you need to install the ggplots, because ggplots come handy in case of forecasting at the post stage, right? So you can install these packages. So I already have that, no problem. So I autoplot the F series which has been created, and it will take some time because it's updating. Successfully unpacked and it is checked, right? So that has been done. And let me just minimize this, and if I see the autoplot, okay, and I run the autoplot, and what do I see here? I get this. Okay, so it was taking a little time because it was installing and updating in the library, and I see this plot, which is this is the original series, and that's how the forecasts are coming. Okay, and which shows that, and these are the errors which are expected at 95 and 99%. Okay, which are substantial. These shadow fangs, we can see it talks a lot about the presence of errors or signals which are left over in our forecast. Okay, so everything is going with what we were working with. It is, this forecast results are as expected from the post hoc test that we have conducted. Okay, so in the end, what last you can do is you can check the accuracy of this forecast by running it. And how do you see it? There are multiple ME, RMSE, MAE, MPE. These are all criteria which finally say about the possibility of these forecasts being accurate. Okay, so it's the most popular one at this stage is considered as RMSE, which is quite high, right? 61.024. We expect RMSE to be very low. It's quite substantially high. So all in all, we proposed our model, we diagnosed it, we used the right kind of a statistics to comment on it, and towards the end, what do we infer from it? There is a possibility of yes, we have run ARIMA, univariate analysis, but there is some more signal which is left over in the residuals, that can be considered as a future scope of the study here, or a further analysis wherein you can pick up some other variables which might be putting pressures or exerting or influencing the data motors besides its own lagged values. So towards the end of this entire analysis, we can write this conclusion that since the residuals are giving signals, so there is a possibility or there is a need to identify some other variables and try to do this analysis of forecasting data motors using bivariate to start with, or multivariate analysis, right? So we do not do an analysis with some presumptions. We state the facts, we propose facts in the right fashion, and propose the right kind of future approach. So that's the process of carrying out the entire time series univariate analysis, starting from data visualization, pre-analysis, during analysis, model building, checking the models with multiple visuals as well as hypothesis test, and then proposing the best model and forecasting and selecting and commenting on the forecast on the basis of RMSE. So here we are closing univariate time series analysis and forecast. Thank you.